we will visit some basic laws on vectors, which is actually the reminder and definition part of our notes. Okay, so having a diagram such, as you can see, vector in direction A and B, and the resultant vector is A plus B. Okay, so A plus B is equivalent to B plus A, and this is called the commutative law for addition of vectors. And this next law is A plus B is obviously equal to or less than modulus of A plus B is less than or equal to modulus A plus modulus B individually. Okay, and addition is also associative. As you can see here, A plus B plus C is also equivalent to if you add A and B, vector A and B first, and then you add it with C, because it's addition, so it's associative. So these are some of the important properties for vectors. Besides that, the negative of a vector has the same magnitude and direction as the original vector, but in opposite sense. Yeah. Okay. Because negative here represents the changes in the direction, but the magnitude is the same. Okay. Next, the fifth property is subtraction of vectors can be defined as addition of negative of a vector. So A minus B equals to A plus negative B. The next important reminder is if you multiply a vector, say U, with a scalar K, so K can be any number or any scalar, yeah? Then the product Ku is a vector in the same direction as the initial vector U. So Ku is in the same direction as the U because the K didn't change the sign. So what happens is it's just that the magnitude increases K times. Okay. Depending on the different K or different scalar value that is being multiplied with a vector. So it will decide how the magnitude increases or decreases. So for example, if K is actually more than 1, okay, so Ku will have an increased magnitude. And if K is less than 1, modulus of K is less than 1, obviously the magnitude will decrease lah. And if K is more than 0, then Ku has the same sense or as U, meaning the same direction. Sense here represents direction, yeah. And if K is less than 0 means if K is negative, then Ku obviously will have the opposite direction of U. Next, we will actually represent this in a figure. So you see, if this is magnitude U and negative 2U here, simply means the direction is being changed simply because the K is a negative value. And according to the commutative law that we discovered in the previous slide, so if it's K plus L multiplied by vector U, so you can split it individually and multiply K and L to U individually and add them up, and it should equal. Same goes with if K is multiplied with U at U plus V. So you can individually multiply the scalar K with U and add it with multiplying K with the individual vector V. When you rearrange it, it should be the same result. So vector direction, when you hold your right hand out in front, and as if you want to shake your hand, so X direction will be your fingers, Y direction will be from palm, and Z direction example is for thumb. Yeah. But bear in mind, sometimes when we draw diagram, I have explained this in semester 1, I remember clearly that if this particular X, Y, and Z direction are actually can be rotatable. That means X, Y, and Z axis are 90 degrees apart each from each other, and it's able to be rotated. Yeah, so when you want to analyze the diagram that gives you a drawing, make sure you analyze what is the location of the X, Y, and the Z axis. For example, if you are given a vector A having components of A1, A2, A3, which represents X, Y, Z respectively, the A1, A2, and A3, then A can be written as position vector in this form: A1, A2, A3, X, Y, and Z. So this is called the position vector A. And if A and B have position vectors A and B respectively, then AB has to be vector B minus A, right? This law is very important, and it's useful for you to actually derive a vectors, yeah. And if P, say a point P, divides AB in the ratio of M to N, okay, then by definition, this will be defined as modulus of AP, modulus of PB, okay, is equal to M over N, right? And how do you identify P? This is the formula to identify P. Bear in mind, B with the underscore is actually a vector, okay? M and N are basically values that define the ratio, how P divides AB. And next, if you have a vector U, for example, with the position being U1, U2, U3 as the components of the vector, and then modulus U, which is also known as magnitude, can be identified simply by using this formula: U1 square plus U2 square plus U3 square, and you set the sum of the three components being squared. Okay, so this is how you actually look for magnitude for three direction vectors. Okay, for a unit vector, it is defined as a vector with magnitude of 1. So for example, a unit vector for U, we symbolize it with UA, equals to 1 over modulus of the vector A multiplied by A. So unit vector, this is the formula how to get a unit vector. Basically, it's the vector over the modulus, right? And unit vector in the X, Y, Z direction are denoted using I, J, and K. So as you're aware, the coefficient of X represents I, and the coefficient of J is Y, and the coefficient of K is Z. Okay, so for example, unit vector in the direction of X, Y, Z, because I is associated with X, so therefore the value is 1, 0, 0 for the components. And for J, J is the coefficient that is related to Y, so therefore Y is the one that has a value of 1 because it's a unit vector. And same goes with K, because K is associated with Z, right? And it gives you a component of 0, 0, 1. Okay, so this is how you write out unit vectors in the direction of X, Y, and Z. Next, any vector you can represent in terms of I, J, K, provided you write out the values in order, yeah. So for example, it's always X, Y, and Z. So 2 is the coefficient that represents X, all right, which is associated with I, and the 3 represents Y associated with J, and the -5 is associated with K because it represents Z. So this is how you actually express vector in the form of IJK, right? Component form, IJK form.